This FedGov Today program is sponsored by Rancher Government Solutions. Welcome back to Naval Research Laboratory's latest developments range from customized aircraft platforms to breakthroughs in insect repellent. Captain Jesse Black is commanding officer at NRL at Sea Air Space recently. He tells me about his command's mission.
The Naval Research Lab is the corporate laboratory for the Navy. So there's a lot of laboratories that are out there like, well, why do we have one for the Navy? It comes back into that maritime application, that maritime domain, and being principled about what is happening and the needs that keep coming to us. We are 10 minutes away from where we're at right now. And you see me representing about 2,700 government employees, 1,800 science and technology, and about 900 PhDs. The laboratory's right over 100 years old. Started off with Thomas Edison and Secretary Daniels. This idea that science and technology needs to be a major player for our warfighters to give our warfighters that advantage. It's been instrumental since that day, since they started. The testimonials are there from radar in World War II into GPS, into the advanced radar systems that we have today. We focus on everything below the ocean floor, through the ocean column, atmospheric column, and into space. So it's pretty wide application of what we touch. Again, to deliver that lethality to the warfighter, it takes time. You know, there has to, science just doesn't happen serendipitously. You have to have purpose and intent to be focused on where you're going, and that's the mission of the laboratory, to do that.
How do you determine what you're going to study, what you're going to research, what you're going to experiment with? Do you get assignments from other parts of the Navy? Do your scientists and experts and others flag opportunities for you to study, some combination of both, something else?
All of the above. Yep. Scientists are currently scouring what's next state of the art. If we talk about quantum technologies and where they're going to be, scientists have been working on that for many years and trying to deliver those technologies for the Navy. But it can be immediate near-term activities like running rust on ships and where we're at with new advanced paint systems and coating systems to save the time frame of the sailors and protect our ships. Admiral Goucher is very much aggressively going after sustainment of that submarine fleet and getting those submarines out of dry docks faster. What technologies do we have for our tank inspections or our monitoring tank systems or helping out with non-destructive testing and engineering? So across the gamut, the influence comes in. We look at the guidance that comes in from the Secretary of the Navy, from the CNO. We look at our portfolios and manage those portfolios to drive towards those needs with what we have.
What are the major portfolio areas that you're working right now, sir?
They are very vast and ranging. Undersea warfare, mine detection, doing things in the autonomous domain, a lot of in the robotics sector. How do we pair machines and humans in this sort of harmonious sense as we move forward? But advancing AI technologies, understanding what ChatGPT is going to do for our sailors and how does that incorporate into making maintenance easier with what folks are doing. Into the biomedical realm of understanding the new proteins that they need to understand to synthesize for a new disease that they may have to get after. So it's wide ranging.
You used a fascinating word there to me regarding the pairing of machines and humans to solve problems, and that's harmonious. I wonder what that looks like and how one determines what the right role of each is to create a harmonious partnership between those two. I mean, I imagine that's one of the really seminal questions.
Oh, for sure. And that's what we think is almost in the near term of what's happening today. You look at great companies like Boston Robotics, who produces a great product. We take that product and infuse it into our Navy environment. What else can we do? Add some neuromorphic chips to it and give it some more intelligence. But this partnership, as we've done in the Navy for a long time, of like 2 personnel going into a job area. Well, we're short on personnel. Can I add an assistant to go in there with them? In these areas, the dexterity isn't quite yet there with the robot, but the human has the dexterity, but they can step track. They can watch the operator doing what they're doing. And we recently, this last year, went to the CNO's office and demonstrated the robotic dog to her and her team. It was pretty remarkable when we dropped a tool the machine, the robot, knew that I dropped a tool, knew that I needed that tool back, and retrieved it back for me and gave it back. But there's a lot of science that happens behind that to understand how they work together. But what was testimonial was when we walked down the hallway of the Pentagon, and all the people like pushed to the outsides. And that was the example where the scientist said, this is what they're trying to drive in human nature, is that the robots are going to be part of us. And the robot needs to be sensitive to the humans, not that the humans need to be sensitive to the robots as they're working. And so it was really testimonial. Yes, sir.
What success have you had in bringing commercial technologies into the work that you're doing, and not necessarily just say, it's not an approval process, but an incorporation process, it sounds.
Well, I'll go right back to the quantum.
Yeah.
We are not working on quantum computing. IBM, Google, INQ, a lot of great companies are working in the compute area. We're working on how do we bring that technology into our Navy environment. And so we partner with them, we work with them about what is it going to mean and how we're getting after this. So I'll go back to corrosion. There's a chemical equation, it's an undeterminate polynomial they've known for years in the chemistry world. We're actually unlocking that chemical equation through a quantum computer married back into a supercomputer to go and solve this problem. So there's that sort of, we're not going to make investments where, folks are already doing that part. Our job is to leverage with them and partner with them and make the best thing for the Navy that we can do.
A lot of the things that you do are really high profile, really sexy. There are a lot of things that you talked about already in this conversation that I think might not even occur to an outsider like me that's important, number one, and number two, it's something that folks are addressing. You mentioned some of the maintenance things that you're getting after and so on. How do those come to your attention as things that are something that you should spend time on?
A lot of times it comes into the business case analysis. It's the dollars or the time spent. A lot of this is in our corrosion branch. We have a corrosion branch down in Key West, Florida that does a lot of corrosion research for the Department of Defense. And it's not necessarily a major whiz-bang kind of project, but it is, anyone knows it's been on a ship, you put anything near the seawater, you're going to have problems. And that sustainment element that's in play. So those dollars drive the science to coming back to new solutions. You can see when the Joint Strike Fighter was coming on the amphib ships, and it would melt the non-skid away. Well, we had to come up with a new way to put non-skid down that wouldn't melt when you brought that fighter in. And so that's kind of like how the technology works and matures in areas that you just wouldn't necessarily think about it's there. But
how does your team look over the horizon and understand what is coming the way that quantum was coming? 5 years ago probably was when people first started to think in government and in the military in particular, this is something we need to be aware of and start to pay attention to. How do you keep your team ahead of that curve to know what they need to be aware of coming next?
This is a beautiful part when you watch how a scientist does their craft, right? It's not only that they're experts in their fields necessarily about this particular topic, but their research that they do. They are masters at scouring the earth for what's happening in the current technologies. What is academia working on, watching that and keeping a pulse on that. And then they have that ability to bring it into the Navy context. And to not appreciate that as much is it's something I've really come to love and watch them do because they are that translator of understanding that to bring the technology into where we're at today. Some of my folks would say, well, what are you doing for me today? What are you doing right now for me? I say, well, your Aegis radar system that you have that's such an incredible eyeball for it to see so far away, gallium nitride and all the work that we did back in the 80s and the 90s, that the fruit is being born today from that efforts that were there. We're currently working on advanced technologies that give them even a bigger eyeball for the future. So it's that sort of knowledge base to know that we have near-term things that they got to do, but it's this long-term investment that takes a lot of years to get after. That's been something I really do appreciate and honor the chance to be able to serve with them and even to share the message with the rest of the community here that there's really smart people working after the right things that the Navy working after to continue to give us that advantage that we need to have. Just like Edison and Secretary Daniels came into this one, it's still relevant and still in play today.